Okay, so the topic is about inverse functions, and they're very easy to draw actually. So what I'm thinking I'll do, just give you a quick example. Now for inverse functions, all you're doing is changing one function and you're changing it. You take a function and you change it a bit. So for example, I've made a description here, but it's probably easier just to show you what's going on. So I'm going to move across here a bit. Okay, so for example, let's make an axis here. Let's see. I'm not sure. I don't like making these axes. So let's see if this works. So for example, if we want to do like one on the side here, and you have a line. So maybe the line goes here. Okay. So it's just a linear function like the one shown on the left here. And then we have points on this line. So maybe it's y equals 2x. All right, so you got a point here. So this is 1. So y must be 2, right? So this is the point 1, 2. And this here, 2, if x is 2, y is 4. So this is the point 2, 4. Like that. And that's 1, 2. And you could keep going. So up here will be 3, 6. And if you had, actually, mine is supposed to go through the intercept. So let's fix the line up. Because I'm going, it should be y equals 2x. So it needs to pass through the axes like that, through the origin here. That's 0, 0. So if x is -1, this will be -2. So it's just a straight line, okay? And these points are all on the line that should be there. Okay, like that. So this is the function f(x) equals 2x. Okay, that's your function. Now, if you want to make an inverse function, we use this notation. It's like a power -1, but it's not. It's just what we use for inverse functions. So now to get the inverse function, we need to swap these points around. So your x point, this is x and y, isn't it? X is 3, y is 6, and x is 2, y is 4. What you need to do is swap x and y. X and y, that's S. So swap x and y around. So if this point is 6, 3, the point on your inverse graph is 3. If that's 3, 6, it becomes 6, 3. So 1, 2, 3, 4, 5, 6. 1, 2, 3 here. So this is the point 6, 3. Okay, so this point here would become this point here. I might use this graph over here because it's already drawn properly. I'll redo it again on this one. So what they're saying is that any point AB would become BA. What I'll do, I'm going to share a different page. Okay, so let me make a new share. We'll come back to this. Where is my graph? Okay. New share, hold on. We want, it's that one, come on, share. Huh? It's not sharing the right page. I want to share. Let me stop this one and find the right page. It should be this one. It's not coming up, hold on. It's actually on my, here, okay. I'll get there eventually. Share. Okay. So you can see this now, this one, right? So on here, I've got a graph. I'm trying to use my pen. So this is the graph y equals x plus 1. You see the green line here? Let's see if I can move this around. So this is y equals x plus 1. So if you look at that graph, this tool here has a pen. I'll see if I can use it. Okay, so this point is 1, 2, right? Let's do this again. This is 1, 2. And this is 5, 6. I'll just choose 2 points. So this is my function. Let's call that fx, which is, it was x plus 1, right? So we want to create a new function f inverse x, a new graph from that. So this is your green line. This is your function. Now what you need to do, and I can't change my pen colors because this doesn't have many functions. So 1, 2 will become 2, 1, which is here. That's 2, 1, right? This is 5, 6, which will become 6, 5, which is here. I'll do another one in a minute. 6, 5. If you have 3, 4, 3, 4 will become 4, 3, which is here. 4, 3. So you see I'm going to get a new graph here. If I've got 0, 1, this will become 1, 0 here. So you have a new graph here. This will be your inverse function. This will be your f inverse x. Okay. The equation for that line, let's take it, it's a straight line, isn't it? It's the same as this one, and it looks parallel to this one here. So you see you've got a y-intercept is -1, right? And your slope is, now for slope of a straight line, we should learn how to do this now. This is called the rise. This bit is called the run. And your slope equal rise on run. And your rise here is 1 unit and your run is 1 unit. So 1 on 1 is 1. So this equation here, f inverse x, is the slope is -1, so minus x, and your y-intercept is -1. That number goes here. So actually for a straight line graph, your equation's mx plus c, right? And m is the slope, and c is the y-intercept. We'll do more on this later, so don't worry too much now. Okay, you got that? So I'll do another example. I really should go back so this all disappears. And I'll come back to it. Okay, so what I'll do, I'll make a new equation. So y, let's do it again, check again. Y equals 2x plus 3, oops, 2x plus 3. So you've got another straight line, okay? So this is your function, fx. Let's get my tool back, my pen. Yeah, this doesn't really have much functionality, but it's the only thing I can find where I can withdraw on the graph from the internet. So anyway, so this is fx, which is 2x plus 3. Okay, don't worry too much about why the equation's like that, but this is the y-intercept, 3, which is here, and 2 is the slope. So I'll show you quickly. This will be your rise, which is 2, and your run, which is 1. So you make a triangle against the line. So 2 on 1 is 2. That's why you get this number here. That's 2 on 1. Rise on run. But we'll do a lot more on that soon. But anyway, so this is your function. And we want to find the inverse function. Where is it? Okay, so you look at the points on your graph. So you see this point here is 0, 3. You see this one? That's 0, 3. 0, 3 will become 3, 0, which is here. So this is a point on your inverse, 3, 0. Pick another point here. -2, -1 would become -1, -2, which is here. I'll just -1, -2. So do you see what happened? All I had to do was swap the two coordinates. So 0, 3 becomes 3, 0. -2, -1 becomes -1, -2. It doesn't matter if it's a straight line or a quadratic or any other kind of graph. This is how you do it to get the inverse. And notice this one here is -1, 1. And that would become 1, -1. 1, -1 here. Notice how we get another straight line, don't we? And at one point, they will be the same. You see this -3, -3. And if you swap -3, -3, you get the same point, don't you? So your line will be here. How about another one? How about this one? 1, 5. So 1, 5 will become 5, 1, which is here, right? So your inverse line, your F inverse will be here. We can write the equation too. We may have a problem there, but writing the equation is a bit difficult from the graph. Okay, we use an algebraic method actually. So what that's looking like, this looks like -1/2, doesn't it? So I think this equation will be, and what is the slope? You see this here? The rise is 1, the run is 2. So we go across 2, up 1, across 2, up 1. So it's rise on run. So 1 on 2 will be the slope, half. And then your y-intercept looks to be -1.5, -3 on 2. That's what it looks like. We'll check these kind of things later, but the easier way is to use the algebraic method. Okay, I'm just reading from the graph to try to get this equation here, but that's how you get your inverse. Okay, so we'll go back to what we were looking at before and take a little bit more there. This one here. Okay, so where's my stuff gone? My picture, there it is. Okay, so basically, the way you can do it, what I didn't show just then was there's a line here, y = x. Okay, that line can be drawn onto your picture. And what you do, your AB will swap to be BA, any two numbers like I just swapped just previously. Now they will go across this line y = x, which is here, an equal distance, and then it would be drawn at an equal distance on the other side at a right angle here. So that's one way you can also do it. So look at this one. So this point here, so this is your function. Don't worry about what the equation is, it's just a line. So we go from, for example, from this point across at a right angle, across the same distance to that point. Okay, so this line's easy to draw. This is just like 1, 1. This is like 5, 5, like that, y = x. So it's just a straight line through the origin here. So this point can go across, and you see that point is going to land on here. You see that there? So whatever this point is, for example, it could be 4, 0. That will become 0, 4, as I just showed. But the point is that you can go from that line, from your graph, go across at a right angle, across to this side at the same distance, like that. And if you look at that, that's like a line of symmetry, isn't it? So this line is actually a reflection of this line. So that orange line or yellow line could be like a mirror. If you put a mirror here and look in the mirror, you will see the red line on the other side. You can try that if you girls, I don't know about the boys, maybe, might have a mirror. So use your mirror, put your mirror on that line here. And then when you look in the mirror, you'll see the red line on this side. Okay, it's like a reflection. That's one way to think about it. But there are, I don't think I want to show this example yet, because this takes, oh, we can show this one. This one's okay. I'm thinking of the next one. So here's your equation, 2x plus 3, which is your function, which is here, this line here, okay? And you want to write down the inverse function. Well, you need to graph it first, okay? So as you see, we take each point or some points of your function and we swap the coordinate. So 0, 3 will become 3, 0. You need at least 2 points, don't you, to draw a straight line. So we have to do it a couple of times. So this point is 2, 7, which you can just get from your equation here or from the graph. 2, 7 becomes 7, 2. So you see how we come down to this point here. So this is your function. And when you join those 2 points, this will be your inverse function, okay? So don't worry about getting the equation yet. We just want to get the graph. So basically the inverse function just comes from swapping the coordinates of your function, all right, when you have a graph. So this second example I'm going to leave for a little bit because this involves some algebraic method. So don't worry about that one yet. So come and look at your exercise here. Okay, what I will show you, I'll enlarge it a bit. And this tablet I'm using is not very good. I've got a better one to use. I'm going to try and get that working. So let me make this bigger. Zoom in. So let's look at this one zoomed in closely. Okay, so it says draw on each graph y equals x. So we draw this line, that's easy to draw, and your inverse. Okay, so let me show you. Let me do the first one, then you think about the other ones. So the first thing we do is draw this line. So that is the series of points, for example, 0, 0, 1, 1, 2, 2, 3, 3, like that. So this line's very easy to draw. Y equals x. So the y value equals the x value. So if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2, like that. So then we just make a graph. So 0, 0 is here. This is 5. So that's going to be like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So about here. So you can put that in now in your book or your tablet. So draw that line in. This will come down like that. It's supposed to be straight. So I think you're better at that than me. So y equals x. So you need to draw that on every graph. So you'll put one in here as well. Now we need to draw this inverse graph. So this point here is 0, 5, isn't it? We actually have 2 points, so we're kind of lucky. We've got 0, 5. And this point is -2, 0. Right, so if you have points that you know, we can just swap them. So 0, 5 becomes 5, 0 here. I'll use a different colored pen now because I can do that on this program. So -5. So 0, 5, 5, 0, 5, 0, like that. That's here, okay? And then you've got -2, 0, which becomes 0 minus 2 about here. Right, so your inverse is going to be here, okay? Mine's not drawn there. That actually should be further down. So let me put that one further down. I think it's meant to be lower. You see the length here? It's got to come down about here. So this is it here. So this is your F inverse. This is your inverse graph, inverse function. And this is your fx, which is given to you already. If you're given the inverse, you just do the same to find the function. You just go backwards. So this is your function here. Your inverse function is here. And if you look at that, you can see it's like a reflection across the red line. And we can draw that down. So let's use, so that will come down to here. This distance is equal. And this is a right angle. Okay, and the same for this one here. Come down. This distance is equal. That length is equal. And a right angle here. So that's also one way you can do it. So I'll leave that one there. You copy that down. And I want you to try these couple here and see what happens. Because this takes a little while to learn. So I'm not really in any hurry of this topic because it takes a little while to learn it properly. So you try the next two here. I'll leave that one there. So put your red line in, your y equals x first. Put that in red or some other color. This is your fx. This is your function graph. And this is your fx as well. I'll put it here. Right, you try those two and see what happens. If you finish quickly, you can go down. So I'll give you 5 minutes. I'll give you till 11 o'clock. All right, try those two. I want to get this green line. I want this inverse. So I guess I can highlight them. So this is your function. This is your function here. So you try to get the inverse function from the graph. See if you can do it. And I'll come back in a few minutes. So I think roughly like that. You're probably better at this than me. So, but that's your y equals x line, or fx equals x. So that's y equals x. So put that in first. Now you need to think, where is this green line here? Where do you put that? So try that, see how it goes. That second one, B, is a little bit difficult actually. You might end up in the wrong place, but try it. If any of you have a mirror, put your mirror on that red line, and then you will see where the green line should be. So if any girls there got a mirror, I'm sure you do. So put it on the red line and see where the green line would be on your graph. We have 1 point, don't we? 0, 4. Well, we don't have any others here. So you might have to think what you're going to do with this bit. So 0, 4, as I mentioned, will become 4, 0 down here. I'll write it above actually. 4, 0, I'll put it up here. So this point is on your inverse. But these points are going to get further away. So I can't see what you're writing, so I don't know if you're right, but I'll give you a minute to think about it. Where's the rest of the graph? Remember, it's a reflection. So look at question A. And you may want to use this idea here. You see that line there? So we're going to go from the graph down to another point on the graph somewhere. So actually, I know this one's probably a bit difficult. So pick a point here on your graph. Now we need to come the same distance to this line and then down again the same distance. So I'll see if I can do it. So come down like that here. So this distance here needs to be repeated on this side. So it's going to be way down here somewhere. So your graph is going to go in this direction. Do you see that now? So imagine it's a line of symmetry. This is really a line of symmetry. So I should write that line of symmetry. It's a mirror line. So this graph is flipped over to be on this side. So that would be your inverse function here. Okay, so this will be your f inverse x. Don't worry about the equation. It looks like part of a quadratic, a part of a parabola. All right, so how about this one? Anyone? This one's easier because you have 2 points, right? So if you look at this graph, you've got 0, 1. And this is -3, 0. Okay, so swap those points and draw your graph. Do that for a minute. We've got 20 minutes, so there's no hurry, but as long as you're following. So 0, 1 becomes 1, 0. So AB becomes BA. They write it like this actually, F, B, okay? And for your inverse function, we swap them. B equals A, like that. So in this case here, I'll use that equation here. So we got F0 equals 1. That means that F inverse 1 will give 0. These are just swapping. This is like your coordinates. So what this is, when you put 0 into your function, you get 1. When you put 1 into your inverse, you get 0. Just notice how they swap there. We're going to use this a lot more later, so don't worry too much about it now. Okay, so 0, 1 would become 1, 0 here. -3, 0 becomes 0, -3, which is down here somewhere. So come across here. And your graph will be here. It should actually pass through that point. I should make the line pass through here. Like that. It should cut through there. There. That's where they are equal. So that's your F inverse. Something like that. It can cut across like that. There. That's your inverse graph. Should be a straight line. Okay, so you just swap the coordinates around. Okay, let's look at D. Okay, let's try these last two. These ones are a bit interesting, these two here. Think about what's happening here. So put your y equals x line in. I will use that as a guide. That's your mirror line. Right, you try that one. And I'll put it in here. But look at this one. It's actually on the line. 2, 2 becomes 2, 2. So your y equals x is actually the same as your function. Okay, that's an interesting one. But generally, they'll be like D. You can draw something different. Okay, try those for a minute. See if you can draw the inverse. We don't need the equations at all for these. We just look at the function and sketch the inverse. That's what this section's about. So that's your function, fx. This is y equals x. This is y equals x. This is your function. And that's drawn there. So try that one. So get your mirror, put on the red line and see what the reflection looks like. And notice you have 1 point here, 0, 1. So what I would do, for me, I'll draw these down. See if this helps. So draw from your graph like that. So I'm just drawing these like reflection lines, I guess you can call them. So this point will go down here. So as I mentioned, these are equal lengths. It's a bit rough. I mean, if you're using a computer, it's much easier to draw this properly, but we don't have computer, so we just got to do it by hand. So that's 0, 1. You should have this point as 1, 0, shouldn't you? That's 1, 0. Now the rest of the points will be here somewhere. So it should come up through that one like that. Do you get something like that? It's not perfect, but you see the idea. So it is easy to put it in the wrong position. But all I'm doing, I'm measuring from the point, a point on the graph, the same distance down to another point. And the same here. So this one, length will equal this length here. And this length here will equal this length here. And that will give you a series of points that you could use to draw the graph like that. If you have the equation, yeah, we can calculate using equations and stuff, but we won't do that just yet. Okay, so in this one, what have you got? You've got the point 0, 2, but the reflection point is actually on the graph. 0, 2 becomes 2, 0. So actually, your function and your inverse is the same graph. Do you see that? If I reflect from 0, 2, I'll end up back on the same graph, isn't it? It's the same graph. I'm not going to get a new graph. If I reflect from a point up here, it will reflect down to here. It's going to be on the same graph because remember we reflect over this red line here. So all of these points will reflect onto itself. So actually your function and your inverse is the same equation. So this here, they're equal. So we can just write fx is equal to f inverse x. It's the same graph. So that was probably an idea. It's a bit difficult to get, but you'll see more on it later on. So we call that a self-inverse. So when you find the inverse of the function, you get the same equation. It's the same graph. Okay, we call that a self-inverse. I'm not sure if I wrote that into the book or not. Okay, so that one's a little bit tricky, but you'll get used to it. And we have the same problem here. If you reflect 2, 2 and you swap, you'll get 2, 2, don't you? Again, so your point is on the line. This is 1, 1. And if you swap 1, 1, you'll get 1, 1. So it's the same equation again. That's another self-inverse here. So you can't, you're stuck on this line. And it's actually equal to that as well. So you could say, again, your function is equal to the inverse function, which is actually equal to x. I could write that there as well, because there's only one line and it's all three equations. Okay, I could probably write that. So that's how that's working. What else have we got here? What have we got? We got 10 minutes. Maybe we can start this. So think about how to graph this. I've got to zoom back. Okay, we've got 3x plus 1. We need to graph this. So if you're not sure how to use slope and rise and run and the y-intercept, we can make a set. So what you should do here, make a table of numbers. So x, and let's go from, oh, it goes to -6 to 16. So let's just choose a few numbers. -3, -2, -1, 0, 1, 2, 3. That's enough, because then you can extend the line because it's a straight line. Can you put those numbers in your calculator or do in your head and then write down the y value? So this is the old-fashioned way, the long way to draw the graph. Okay, I want a few points though, because I want to find the inverse. So if you put -3 in here, you'll get -9 plus 1 is -8. Okay, you try that for a little while. And let's see if we can draw this 3x plus 1 line. Okay, it just means you have more to do by yourself on the worksheet when you get it, if you don't do it now. So, okay, have a go with that. So make a series of points and then draw the straight line. And we also want y equals x. That's an easy one. So I can do a bit of that. So that would be 0, 0, 2, 2, 4, 4, 6, 6. Like that. So that's y equals x. So that's the first thing you need to do. And then come back here and fill in your table. So if we do that, we got -2, -6 plus 1, -5. So fill that in. -3 plus 1, -2. 1, 3 on 3 plus 1, 4. 3 2s are 6 plus 1, 7. 3 3s are 9 plus 1, 11. So these are your series of numbers for your function. So you've got -3, -8, -2, -5, like that. Now these are for your function, for drawing your function. So we'll write that there, fx. Now when you draw your inverse, we will swap these pairs. So that would become -8, -3, -5, -2, like that, okay? And you draw that second. So what do we got? -3, -8. That's not, that's too far down. So -2, -5. So -2, -5 is here. -1, -2 is here. Zero, 1, 1, 4. So 0, 1, 0, 1, 1, 4. So you can't go too far. It's going to go up this way. This will be your function. Can I get to 2? 2, 7, too far. So 7 is off the graph, unfortunately. So your function will be here. So let's do that in black. And you're going to pass through somewhere here. It passes through there. So this will be your function. So review the video later before, if you're still having a problem. Okay, so that's your function. So we have, now we can find our inverse. So we do -3 minus 8 is -8 minus 3, which we're not going to do. -5 minus 2. Okay, so -5 minus 2 we can do, which is here. Then we have -2 minus 1. So -2 minus 1 is here. That's in between. It's a bit tedious, isn't it? But it doesn't take too long. 0, 1 becomes 1, 0. So 1, 0 is here, and so on. So you keep drawing them out. So 1, 4 will become 4, 1. 4, 1 is here. Then 2, 7 becomes 7, 2. You see, all it is swapping coordinates, 7, 2. So the graphs will come out eventually. Okay, time nearly up. So we'll just finish this graph. And then we'll learn how to write the equation more on the next lesson. So 3, 11 will become 11, 3. 11, 3 is about here. So you're going to get your inverse, and it will pass through here. You see that point where the red and black line touch? The inverse will also touch there. So this will be your inverse graph. Straight line, not, well, it should look better than mine. So this will be your inverse. Okay, so your 1, 4 becomes 4, 1, etc. So this here is 1, 4. And when you reflect down, it will become 4, 1 here, like that. So you basically just swap your coordinates to get your inverse graph, and that's it. You're going to see inverses a lot more in future if you do anything with maths. So something we're going to have to get used to. And I know you probably don't like graphing, but anyway. So we can write down the equation from the graph, but I'll show you a better way to do it on the next lesson. So we may continue with this tomorrow, and then I'll use the last lesson for the set. Go back to the real number and do some more on that. Okay, is that all right? So if you're doing it without a tablet, if you're just doing it on paper, you're going to have to take notes about this, okay? Because it's something is more useful if you have a tablet. It's easier to do. All right, I'll talk to you tomorrow then, because it's 12:20 already. Yeah, 12:20, so we need to stop, all right? Okay, so I'll talk to you on tomorrow then, is it?